Welcome to Math 0314, section 4.2. We're going to be talking about polynomials. So what is a polynomial? Well, a polynomial is in X is defined as a finite sum of terms with the form ax to the n, where a is a real number and the exponent n is a whole number. A is called the coefficient and n is called the degree of the term. Okay, so that's saying a lot, but essentially a polynomial is of this format right here. You will typically see it in the format of something like 3x squared plus x plus 7. Okay, what this is saying is this value here is called the coefficient. This value here is obviously, this is the variable with an exponent of 2. Okay, so what's important here is it says where a is a real number. Most of the numbers we've played with are real numbers. The common number that we will talk about later on in the semester that's not a real number is called an imaginary number. But most of the time, so this could be 3, this could be 1/3, it could be 0.7. All the types of numbers that you're used to seeing can exist. The thing you want to look out for, though, is the exponent is a whole number. So remember, a whole number is 0, 1, 2, and 3, etc. Okay, so this can't be a fraction. That's the important part. It can't be a negative number. And those are the things to look out for when you're looking for polynomials. Okay, but most of the time, the question is not really going to ask you to state the polynomial. It will just give you a polynomial. So when we come across situations like that, we won't see any in this video, but in the future videos, we'll come across certain situations that may not be polynomials, and we'll point out what's not a polynomial and what that may look like. But for the time being, let's take a look at what we will be seeing in this section, which is for each term, write the coefficient and degree. So the coefficient is the number in front, so this would be, I'm just going to write C for coefficient. The degree is the exponent. Now, one thing about here is n is called the degree of the term. Okay, so we want to make sure here this says degree, so this would be 5. There's a difference between degree of the term and degree of the polynomial. The degree of, if it says degree of the polynomial, I'm just going to write I can write polynomial, then what it's referring to is the highest exponent. Okay, so or if you have, let's say something like xy and x squared cubed, something like this, we would sum these up and that would be the degree. So keep that in mind. You have to read very carefully in terms of what it's saying in order to make sure that you're answering what the question is. But here we're looking for essentially what's the exponent. So if you look at the second one, if I ask you what's the coefficient, be careful. There's technically a 1 here. Sometimes people think because there's not a number they'll say 0, but this is the coefficient and this is the degree. I guess I should put D here instead of rewriting 5, huh? So we'll put a D here. Okay, with 7, realize this. Remember we said x to the 0 is 1. So this is technically 7x to the 0. So I would argue that this is 7 and this degree would be 0. They may say it doesn't have a degree, but I think that's more of the accurate response. And in here, of course, coefficient is the number in front, which is 1/2. And though there's not one, remember it's not 0 because 0 would mean that it's 1, right? Not literally the exponent. All of this would be the same thing as 1. If this has an exponent of 1, I'm sorry, if it just has a letter, which is a variable, the variable has technically an exponent of 1. Okay, so if there's nothing there, it's 0. But if there's something there, then it's 1. If there's just a letter, it's just 1. It doesn't matter what the letter is, right? 1, 1, 1. Okay, so hopefully that's clear. Let's keep moving on. Next up, so this is long. The directions are longer than the problem. It says for each polynomial, rewrite the type. Is it a monomial, binomial, trinomial? So what is a monomial? Everything that we just saw just now in this section here are monomials. So it's when you have just one term, okay? Binomials are when you have two terms, okay? And note, it doesn't have to be x squared in the number. It could be x plus 3. It doesn't matter what it is. It just what we're trying to say is that you have two things in between plus minus. Okay, trinomial would mean, oops, you would have 3. Okay, trinomials are what you will see as we progress in this course, and trinomial would be something usually. I'm sorry, this is the typical type of trinomial that you'll see as we progress through this course. So we're going to get exposed more and more to this exponent of 2 and what that is. So stay in store. Plenty to look forward to. Okay, the next part it's asking is to write in descending order. So descending order is that we write the exponents decreasing. So notice I did that with these two examples. Actually, I did that with every example. So highest to lowest. So you go 3, 2, 1 in terms of the exponents. We want to write it with the leading coefficient. So the leading coefficient is the number in front. Notice in all of these, because there isn't a number written, that number is 1. And the degree is, let's argue that we're going to write the degree of the polynomial. So the degree of the polynomial would be the highest exponent. Okay? So if we look at the first one, we know that this is a monomial. Okay? We know, because it's only one term, descending order, it's already written in descending order because it only has one term. Leading coefficient would be the number in front, so this would be the leading coefficient, would be 2. It's the only coefficient. And degree, because there's only one exponent, it's going to be 9 is equal to the degree. Okay, so take a look at these questions. Let me scroll through them. I think I have a couple more on the other page. No, that's it. Take a look at these next 4 and work them out. See if you can figure out what the type, descending order, leading coefficient, and degree are. So I'm going to assume that you paused the video, gave a shot at it, and let's go through it together. So again, this is going to be a monomial because there's only one term. Okay. The leading coefficient, so this is what's called, when it's just a number, it's called a constant. Now, how you interpret this can mean a lot. I think our book just says it's a constant and that's it. But we could technically interpret this as negative 49x to the 0. And if I interpret it this way, this would be my leading coefficient and the degree would be 0. Okay, but I believe the book calls it just a constant. So I'll accept either. All right, number 3, this is the first one. It's a little different. We have 2 terms here, right? So this is a binomial. Bi means 2, right? So binomial. We can rewrite this in descending order, and what's extremely important here is that we have a negative sign in front. So when we write this, the 7, because the 7 is attached to a squared, whereas the 10 is only attached to a 1, when we write that, we want to include the negative. Okay, the leading coefficient is going to be negative 7, and the degree is 2. That's important as well, right? This one now has 2 different sets of terms, and the degree is the highest exponent. Moving right along. Let's do this in a different color. This one, again, is still a binomial. We could rewrite it as negative 2/3 b plus 6. Notice I took the negative sign with the negative 2/3. And this does have an exponent. It's 1. So hence the degree is 1. And the leading coefficient is the number in front, which is negative 2/3. Okay. The last one, and again, I'm hoping that if you are missing these but you start to understand it, you would pause the video and try it on your own. But in any case, this one has 3 terms, so that we would call this a trinomial. If we were to rewrite it, we would write in descending order. It'd be 9w to the 6 plus 2w cubed plus w. The let's just go with brown. The leading coefficient would be 9, and the highest degree would be 6. I'm sorry, the highest exponent, which would be the degree, would be 6. And there you have it. All right. This next bit is more of what you're really going to be doing and more of the important part for future math courses, which is we're going to be simplifying polynomials. Okay, so what this means is we're just combining like terms. So I'm going to put anything that's cubed, group those together. I'll put them in this orange box. Squares will go in a triangle. And I'm randomly choosing the shapes here. And a circle is going to represent any x term. Okay, so we can put these two together where we're adding. So there's technically a coefficient of 1. So we have 3x cubed plus 1x cubed, and this would give me 4x cubed. There is nothing to go with the triangle, so that's going to be just 2x squared. And then we can put these two together. Notice they're both negative, so this would give me negative 11x. And that would be the simplified version. So all we're doing here is combining like terms. And if you think about this in terms of real world scenarios, this makes perfect sense. Okay? When you cube something, you are talking about, one way to look at it is you can talk about volume. Something in 3 dimensions has something like length, width, and height, right? So that's going to be, we're talking about something like volume. When we have 2 dimensions, that's like area, right? It's like the square foot of your home, right? And if you have 1 dimension, that's like length, right? Like how long is your pencil, right? It wouldn't make sense to take the volume of something and add it to an area, or an area and add it to a length, right? So it wouldn't make sense to say, let's say your home is 1,600 square feet, right? And then you're going to add 7 feet to that. You can't do that because your dimensions are not the same, right? They have to match up. And that's exactly what's occurring here. So I always try my best to relate math to the real world. I think it makes it these abstract ideas more concrete. But in any case, take a look at number 2, see if you can solve that on your own. And let's go on and take it together, assuming that you've already solved this and you paused the video. So you'll see I'm putting the w squares together. I'm putting the w's together. And I'm putting just the numbers together. So we would have to put 2/5 w squared together with 4/3 w squared. And we would have to put negative w with 8w. And then we'd have to put 1/8 with negative 1/4. Now, don't let these fractions scare you, right? Here, all we're doing is putting 2/5 together with 4/3. So we would have to find a common denominator. Remember, one way to deal with this is to use what's called the Xmin Rule. If you took me from the previous course, you may recall this rule. But essentially, the Xmin Rule is of given a over b plus c over d, you can get AD plus BC over BD. And that is always true. If you think about it, this is true because you have to get the bottoms to match, right? So if I have B on the left and D on the right, then if I just multiply the top and the bottom by D over D, and on the right side B over B, I would create a common denominator of BD or DB depending on how you look at it. But what happens on the top? You're getting A times D or D times A, and then C times B or B times C, right? And that's exactly what I'm saying here, right? Because what you're really doing is you're multiplying to get these bottoms to match, you're multiplying by the other one. Hence, that going diagonally would produce the results that I need. Okay? So hopefully that makes sense. If you would prefer doing it the traditional way, you can as well. But let me clear this out and let's go ahead and do that. So hopefully, as I clear this out, you are multiplying through, trying this method. By the way, I call it the Xmin Rule. It doesn't have like an official name for it. I've never heard of an official name for it, so I just call it Xmin. So we're going to do 2 times 3, which is 6, 5 times 4, which is 20, and this is all going to be over 5 times 3, which is 15, and this is w squared. So this is 26 over 15, w squared. This part here is pretty straightforward. 8w minus w is 7w, so plus 7w. And here we can use the Xmin rule. There is a drawback to the Xmin rule, which is that you don't get the most reduced state all the time. I think it's pretty obvious here that this is, can change it to a common denominator of 8. So this is 1/8 minus 2/8, which becomes negative 1/8. And there's our answer. So that took a little more time, but it wasn't really because of the idea that we just learned. It's because we were playing with fractions. So if you'd like to see more examples of me using the Xmin rule, let me know, and I'll go ahead and do that for you. All right, let's keep going. So on this one, we're complicating the fact by putting more than one letter in here, or more than one variable, but it's still the same game. They have to match up. So we see a squared b matches up with a squared b. We can see 7ab matches up with negative 2ab, and 6 matches up with negative 7. So, and the shapes or the design of how to map it up is totally up to you. In fact, you don't even have to do that, and eventually I'm going to stop doing that. Keep in mind, though, here when we do 1a squared b plus 5a squared b, we're going to get 6a squared b. One other note here, as we work through these, please do not hesitate as you work through and you solve these problems. If some sort of method I mentioned before is helping you and I stop using it in future videos, if it helps you and you need to keep doing it, don't stop using it, right? I tend to stop using certain techniques that I initially use just because it starts eating up time in the videos, and I only have a finite amount of time. So let's keep going. So we're going to put 7ab and minus 2ab together. That's going to give me 5ab. And then we're going to put 6 minus 7 together, which is negative 1. And that's it. So the concept is very simple. The backs got to match up. When the backs match up, you put them together. This next one is different, and I hope you realize how it's different. And so answer that question about how this scenario is different than the previous ones. And hopefully what you said is that you do have the negative sign, which means I must distribute this negative into everything. Remember, though, that distributing a negative into everything is nothing more than rewriting it with the signs changed. Okay? And so, again, we can combine like terms. Now, one other way of doing this is the vertical method. And the vertical method is that we line them up vertically, one on top of the other, and then just add as if you were adding. You're back in grade school and you're adding. So this would work out to give me that. So if the vertical method helps you to see more clearly what matches up, go ahead and use that. Note all I did was take this and write it directly below. If you don't like that, you don't have to use that. And I'll be honest, personally, it's easy enough for me to say, okay, this matches up with this matches up with this, and this matches up with that. So I'm not too fond of it, but if it gets really ugly, sometimes I do use the vertical method. Okay, so go ahead, pause the video, take a shot at this, and I'm going to assume you did so. Pretty much the same. We're going to distribute. Note the first value, it was originally negative, so now it's positive, and everything else remains the same. We're going to recopy this second side. So let's put stuff together. Let's put terms together, I should say. So we can put 6a squared with 3a squared. We can put negative 2a with negative 2a. And negative 3 has no friends. So let's keep putting stuff together. 6a squared and 3a squared is going to give me 9a squared. Negative 2a is going to give me negative 4a. Note they're both negative, so we add them. And negative 3 doesn't have a friend, so we just write it as such. Awesome. Let's keep going. Go ahead, pause the video, give this one a shot on your own. And I'm going to assume that you just did that and we can talk about it. It's really more of the same. It's trying to intimidate you with the fact that we have multiple letters in the terms, but it's just making sure once you've distributed the negative that what's alike matches up with what's alike. So 6x squared y matches up with negative 1, there's technically a 1 there, x squared y. Negative 2xy has no friends, so it's sitting there by itself. And then 5 and negative 3 can hang out together. So let's put them together. So we have 6 going with negative 1, which gives me 5x squared y. Negative 2xy has no friends, and 5 minus 3 is 2. And there's my answer. Okay? Apologize, I should have done the negative 2xy in yellow, and then the 5 minus 3 in brown, so it stays color-coordinated. But you get the idea. Alright, once more, pause the video, give it a shot, see what happens. And once more, I'm going to assume that you have paused the video, you've given it a shot, you found out what happens, and let's see if my work matches up with yours. So, I'm going to distribute the second one. And so this gives me negative 2p squared q minus 4pq minus 4. Remember, they have to match up exactly. So 7p squared q does match up with negative 2p squared q. Negative 6 is just a number that goes with negative 4. And negative 4pq doesn't have any friends. So let's put them together. So we can put these two together. It's going to be 5p squared q. I'm putting this in descending order, so I'm going to rewrite the brown one first, and then I'll put the constants together. So we'll put the yellows together and get negative 10. So the way you decipher this when they're not just one term, it's the sum of these. So 2 plus 1 gives me 3, so that comes first. 1 plus 1 is 2, that comes next. And this has nothing, so this would be 0, and so that comes last. And there you have it. So you're just matching stuff up, and you're adding or subtracting, matching terms up and adding and subtracting. Okay, so this one's a little longer, but more of the same. Pause the video, give yourself a shot at it, and I'm gonna again once more assume that you've done that. I'm gonna try to write little tiny so that I can fit them all in. Once we get to the parentheses, we have to distribute and change the signs. Excuse me, sorry about that. Alright, so there we have it. Alright, let's match them up. So x to the 4th, negative x to the 4th, 1/2 x squared, 3/4 x squared, negative 4x, and then we have negative 1/5. Okay, so let's put the purples together. So we have 3/2. So 3/2 minus 1/2 is just going to be 2 over 2, right? Which, well, let me write it this way. It's going to be, so this would be 3/2 minus 1/2, which would give me 2 over 2, which is 1. So this is going to be 1x to the 4th, which we usually just write as x to the 4th. 1/2 plus 3/4. Here we're going to have a common denominator. And you could use the Xmin rule here, but here I'm going to actually multiply 2 and 2. And the reason why is it reduces it faster, and it's easy enough to note that the common denominator is 4. So this will give me 5/4. So let me do this. Let me put this x to the, what did I say, x to the 4th. Let's put that a little lower. And this is going to give me 5/4 x squared. And the rest of it doesn't match up. So the negative 4x is just negative 4x. And the minus 1/5 is just minus 1/5. And there's my answer. And that's it. So what makes number 8 maybe a little bit more tedious, I wouldn't say difficult, just tedious, is the fractions, right? But we've been playing with fractions throughout this course, and I hope that your awareness of how to deal with fractions has increased immensely. Alright, number 9 is more of the same. Pause the video, give yourself a shot at it, and let's go over it together now. So we're going to have 1/3 p cubed plus 3/4 p squared minus p. We're going to distribute the negatives into all of these. So this is going to be negative 1/2 p cubed minus 1/3 p squared minus 1/2 p. So we're going to put the p cubes together. We're going to put the p squareds together. And we're going to put the p together. Okay, so 1/3 minus 1/2. Here's a golden opportunity to apply the Xmin rule because it's not so clear. The common denominator, let me put it this way, the common denominator is going to be 3 times 2, which is 6. So why not just use the rule? So this will give me 2 minus 3 over 6, which is negative 1/6. Which makes sense, right? Because 1/3 is less than 1/2. Think about a pizza. If you cut it up into the thirds versus cutting it up into halves. So this is negative 1/6 p cubed. With the green, we're going to have 3/4 minus 1/3. This is another opportunity to apply the Xmin rule. So this is going to give me 9 minus 4 over 12. Which will reduce to 5 over 12. I'm just going to bring all of this down. So this is negative 1/6 p cubed. We now have plus 5/12 p, I believe it's p, yep, p squared. And then we'll go on to the next one, which is we have the brown, which is negative p minus 1/2. So we have negative 1 minus 1/2. Negative 1 is the same thing as negative 2 over 2 minus 1/2, which is negative 3 over 2. So the back part, negative 3 over 2. And this again was p, because these were p's. And there you have it. So again, if you're having issues, it's probably you're having issues with playing with fractions. But the actual math portion of this is just combining what looks alike, and it's pretty straightforward. So if you're struggling with fractions, let me know, and I can maybe post a video about that. Alright, number 10. We've actually done this, so hopefully you're aware of what to do. All this is saying is that instead of x, you plug in 1, which is back in chapter 2. So now I'm replacing all my x's with 1, so this becomes 1 cubed is 1. Note here, you have to do exponents first, so 1 squared, which is 1, and then multiply by 2. So watch yourself there, minus 1, minus 2. So we can very clearly see that the 1 and minus 1 we get 0, and 2 minus 2 gets me 0. So the whole thing is equal to 0. The next one is with negative 3, so we have negative 3 cubed plus 2 times negative 3 squared minus negative 3 minus 2. So when we solve this, notice negative 3 cubed is negative 27. Over here we have to do 9 first. 9 times 2 is 18. Minus 3. Wait, sorry. We have minus 3, which is actually plus 3. This is minus 3, which is plus 3, minus 2. So when we put this together, we're going to get negative 9. This is negative 9. Plus 3 is negative 6. Minus 2 is negative 8. And so on and so forth. So I'm actually about to run out of time in this video, so I'm going to stop here, and then I'll have one little short video wrapping this up. See you all in that video.